Okay, so what I want you to do is go ahead and click on the armature and switch this to pose mode. Go ahead and click on this bone, do Shift S and do cursor to selected. Do Shift A and then add a circle. Now over here, you're going to make sure that this is set on nothing for the fill type. Now press the tab key to go into edit mode and press the S key to scale this circle down like so. Now of course you're going to go to the object tab and enable X-ray so we can see the circle through the figure. Now press the period key on your numpad to home in on this. Now do Shift D to duplicate, right click to cancel, and press the R key. Press the control key down and rotate this by 90 degrees. Press the 7 key to go to your top view. Do Shift D to duplicate, right click to cancel. Press the R key, press the control key down and rotate this by 90. Now press the tab key. So here when we position the view like this, you can see that all we've done is really exposed the pose space coordinate system or its planes on the head of this bone. So this is going to be true for every bone that you set up in your armature. Now when we click on this bone and switch this to edit mode, you can see that when we take a look at how this bone is set up in edit mode and when we look at these planes, so when we do Alt R to reset the bone rolls to 0, you will see why the Z-axis is pointing this way, right? This is because the bone's rotation over here is closest to the XZ and the XY planes. So you can click on this bone over here, go to the bone tab and remove the connected. Now you can click on the tail of this bone and visually make sure that you've selected this bone over here and press the R key 2 times and go ahead and bring this bone closer to the XY plane for the circle. Now when you click on the body of this bone, do Alt R, of course the Z-axis is going to point up because we just saw this when we were looking at bone rolls. Now in the same way, when you click on the tail of this bone and let's say rotate the view like this, so we want to bring the tail of this bone, let's say closer to this plane over here, press the R key 2 times. Let's say we bring it right around here, okay? Very close to it. Now here, when we click on the body of this bone and do Alt R, you will see that the Z-axis is going to be pointing this way, right? Because we saw this is how this idea of bone rolls work when we set the bone rolls to 0. Now press the 1 key. Now go ahead and click on the head of this bone, do Shift S and do cursor to select it. Now click on the tail of this bone and do Shift S and do selection to cursor. Go ahead and click on this bone and enable connected. So when you have the body of this bone selected, you can see that we of course can just set the bone roll to anything we want, right? And how we position the bone in edit mode, this will determine the local coordinate system that the bone will use, meaning how do you plan to use this bone in pose mode. Now press the 1 key and now go ahead and switch this back to pose mode. Now this brings us to the next item that we are going to look at before we dive in to the module-based rigging system, and that has to do with these rotation modes that we can set up on our bones or objects. So here you can see that when we look at the rotation modes displayed over here, we can choose axis angle, or we can choose 6 different Euler angle configurations, or we can choose quaternion. Now by default, Blender is going to set each bone to quaternion. And on the object, if you click on the figure, the default will be set to XYZ Euler. I'm going to go ahead and click on this bone. So here we're now going to take a look at what is rotation mode. Now, the thing you should know, or actually once in your life, take the time to understand the history of rotations in mathematics in general. So there you will find that this idea of Euler rotations is coming from the 17th century. Axis angle and quaternion are coming from the 18th century. So we still use these concepts today, not only in a Blender, but basically all 3D modeling packages. So we're going to now take a look at what these concepts are. So what I want you to do is, let's go ahead and just save this file over here, and we're going to do File, New, and you're going to do Reload a Startup File. Go ahead and click on this camera, press the Shift key down, click on this lamp, do X and delete. Click on this cube and go to the Object tab, enable the axis and name, and let's switch this to wire. Now press the period key to home in on this. Go ahead and zoom out a bit and now press the 5 key to go back to orthographic view. Now what we want to do is actually go ahead and just rotate the view kind of like this first. And now here we're going to do File, Save As, and make sure that you save this file as capital A, Rotation Concepts 1.blend. The reason we added an A is because it allows the file to show up on top. Go ahead, now save. Okay, so what I want you to do is go ahead and open this up. When you add objects inside the 3D view, the default rotation mode will always be set to XYZ Euler. This is on the object level. When you do Shift A and add an armature with a single bone, on the object level, the armature will be set to use XYZ Euler. When you switch this to pose mode and click on a bone, the bone by default will be set to use quaternion. You can click this and change the rotation mode to anything that you want. When we are dealing with deformed bones, we're going to leave them on quaternion. When we are dealing with non-deformed bones, we are going to be using quaternion and Euler rotation. It depends on what you want the bone to do when it comes to rotation. Euler rotations, as you will see, are good to use when you are only expecting the bone to rotate around a single axis or two axes, such as the knee joint, the elbow joint, and the finger joints. But everything else can be set to use quaternion. We of course are going to understand how these concepts work. If you are using Blender and you only want to model 3D objects so you can render out a picture, the rotation mode is not going to pertain to you. You're simply going to leave all your objects on XYZ Euler. This again has to do with animation. So this means we are talking about interpolation, how the object's rotation will change from keyframe to keyframe, meaning how the rotation interpolation will happen. So depending on what type of rotation mode you choose will give you different type of results. So to understand this concept, what I want you to do is go ahead and switch to object mode, do X and delete this. Go ahead and click on this object. When we are dealing with rotation mode, we are going to be dealing with two additional window types. Here, go ahead and switch to Graph Editor. We are going to be looking at this briefly, and of course we're going to be dealing with the dope sheet. We're going to be looking at this briefly. go ahead and switch back to 3D view. Now, to understand what exactly happens to an object's rotation, depending on the rotation mode that you choose, we have to see this visually. So what I want you to do is click on this object and press the tab key to go into edit mode, do W and subdivide. Now go ahead and just click on this vertex, press the E key, and then right click to cancel, and press the 1 key to go into your front view. Do shift middle mouse button to pan over here. Click on this blue arrow and just expand this over here. This is just a visual thing that we're doing. Now do the middle mouse button, press the shift key down and click on this vertex. Do Control I to flip the selection, do X and delete the vertices. Go ahead and press the 1 key and now press the tab key. Now make sure that the 3D cursor is in the center, do Shift C. Now go ahead and do Shift A and add a UV sphere. Press the S key to scale this down, kind of like this. Having the sphere selected, press the Shift key down and click on this object and create a parent-child relationship. Do Control P and select Object. Click on this sphere and go ahead and click on the blue arrow and move it up over here. This sphere on top is going to represent how the motion path will be for the XYZ Euler. Do Shift D to duplicate, right click to cancel. Now go ahead and click on the blue arrow and bring this down, kind of like over here. This will represent when we switch this to quaternion. We're not going to do this on the sphere. We're going to do this on the object itself, the axis. Do Shift D to duplicate, right click to cancel, and now bring this down. This will represent the motion path when we use axis angle. Now what I want you to do is go ahead and click this. Go ahead and do the middle mouse button to rotate. Now over here, make sure you click this so it goes to frame 1. Here we're going to press the I key and insert a rotation keyframe on this object. Now go ahead and go to frame 50 by clicking your left mouse button over here. Now here we're going to press the R key and press the Y key. Go ahead and rotate this, press the Control key down and just rotate it by 90. You can look over here or you can look on the header when you did this. Now press the I key and do rotation. Now go ahead and take this to frame 100. Press the R key, press the Z key. Now go ahead and rotate it like this. Press the Control key down and do it by 90 again. Now press the I key and go ahead and do rotation again. All we're doing is capturing the rotations in these keyframes. Go ahead and now switch this. Let's take this to 150. Now press the R key, press the X key, and we're going to rotate it back up. Press the Control key down and rotate it by 90. Do I and rotation. Now when we did this, what I want you to do is go ahead and expand this over here and now switch this to the graph editor. Because we have this object selected, open this up. You can see that over here we've captured the keyframes. Because this object was set on XYZ Euler, this is what the graph editor is showing. You can press the period key to home in on this. This is basically showing you how much on each individual axis we have done the rotations. This is what these numbers are representing, the amount of rotation. And over here, these numbers over here are representing your keyframes. So you can see that when we have the X Euler rotation red thing selected, that's what it's highlighting. It's just showing you this in a curve. So you can see that this is how this is moving. Okay, anyways, go ahead and click this over here. Now over here, we're going to click this and close this. Now what I want you to do is go ahead and click this object, go to the Object tab, go down, go to Motion Paths, and click on Calculate. And just click on OK. What you're going to see is a motion path, meaning that what this sphere is showing, that when this object rotated, this is how the motion path is going to be. So over here, if we start to move the keyframes, you can see that here the object moved correctly, and over here it moved correctly, but over here something strange happened to the object. It started to curve. You can press the 7 key to look at this from the top view. This is not making sense. This has to do with gimbal lock, meaning that this object was set to use XYZ Euler. We're going to understand this concept a bit better. So you can see it really does matter as to what type of rotation mode that you are selecting, right? So you have to understand the type of animation that you are expecting to do on your object. If your object is going to be rotating in a sophisticated way, meaning rotating using the X, Y, Z axis, then the Euler rotations are a sign of trouble, because Euler rotations are best used when you are expecting to rotate the object on a single axis or two axes. But if you start rotating an object on all three axes, you're going to start to hit this concept of gimbal lock. We're going to understand this in detail. I just want to show you that this is what's going on. Anyways, go ahead and now click this to go back to frame 1. Now if we open this up over here, actually close this, go ahead and expand this up over here and go back to the graph editor, you can see that all we've done is capture the X, Y, Z Euler rotations. When we have this object selected and now switch this to quaternion, you will notice that when we move this, right, the object has stopped rotating. This is because when we switch this, the X, Y, Z Euler rotations are not going to be used, but they will still stay intact. This is what we want. So go ahead and now click over here to go back to frame 1. So here I'm just going to actually expand this down over here and do the same thing. Okay, so here on frame 1, we want to press the I key and now do rotation. Notice that now we're capturing the quaternion rotations. They're going to come through. So we're going to do the same thing. So now go ahead and take this to frame 50 over here, press the R key and press the Y key, press the control key down and rotate this by 90. Do I and capture the rotation. Go ahead and take this to frame 100, press the R key, press the Z key, press the control key down and rotate this by 90. Do I in rotation. Now go ahead and take this to frame 150, press the R key, press the X key, press the control key down and rotate this by 90 over here. Now do I and capture the rotation. Now when we have this set on quaternion, we can go ahead and click on this second sphere, go back to the Object tab, go over here Motion Paths and do Calculate and do OK. Now go ahead and click this and collapse it. Now when you press the 7 key, you can see that when we are dealing with quaternions, we're getting a much better result. Okay, so we're going to look at this concept in a bit more detail. So what I want you to do is go ahead under File, now do Save As, and save this as Rotation Concepts 2.blend. So I'll see you in the next lesson. Thank you.